So, good afternoon. Good afternoon. This is Dr. Faisal. I am going to uh, give you a lecture on Pascal's law. That is on a topic in fluid mechanics in third sem. So, by this lecture, we will be able to understand what is Pascal's law, what are its applications, and how we can use it. Okay. Now, Pascal's law, and as and when an external pressure is applied to an enclosed fluid, it is transported uniformly throughout the volume of that liquid. In an enclosed container, if external pressure is applied, that pressure will be uniformly distributed throughout the volume of that liquid. This is basically a Pascal's law. You can see here in the captions that pressure in and pressure out will remain the same. Suppose there's a pipe on the left side, you see there is a small diameter, that is A in, and the force F in is applied. And on the right side, you can see a force out, and the area is a little bit larger, that is A out. So the pressure on both sides will remain the same as per this Pascal's law, whereas the force is the area and out respectively. So pressure will remain the same. That means force per unit area will remain the same. Now, applications of this Pascal's law, we can say that since there is change in pressure is equal in all parts of the system, any input force applied on the smaller area is multiplied by several factors. If the output piston has a larger area, the force will be multiplied. That means that whenever the area has been increased, so it will be the number of times the area has been increased, that will be the force will be multiplied. For example, Pascal principle, the application include hydraulic crane, hydraulic lift, hydraulic jack, and hydraulic brake systems. These are the examples of Pascal's law and applications of Pascal's law which have been used here. You can see here on the left, small area is there in the left side, and small force is applied. That is force per unit area, and it is lifting a car which is much heavier. And because the force in area has been large, it is multiplied. So force per unit area on the left is multiplied by the factor A2. That is the size of the piston or cylinder on the right side. The other applications are hydraulic jack. You can see in this example what is an hydraulic jack is. A simple platform is there, a fulcrum is there. When a force is applied to this smaller cylinder, this wall is open, and it against used to lift that platform load which is then on the platform. Like heavy trucks can be lifted in this manner, and it gives a mechanical advantage. In this manner, we can get a mechanical advantage by using a small force. A large amount of force can be lifted. And other example is these hydraulic brakes, which we usually used to say in local language, that is power brake, right? And hydraulic brake is the same here. There is a master cylinder, and when we push the pedal, this pushes the cylinder. This pushes the piston or inside this enclosed liquid in a pipe, and the force is applied. And here, where there is a master cylinder, and the master cylinder, or where the brake force is applied, there is a bigger, larger cylinder. Hence, the force will multiply, and the brakes are applied in this manner. And again, when the pedal is released due to spring action and due to other reactions, it will be released from the brake drum. The brake shoe has been released from the brake drum. So these are the few applications of Pascal's law which have been we have been seeing here. Now the other part is there's example numerical on various numericals used to come. You used to face students to face it. So there's one simple numerical, and that example is two pistons of hydraulic lift have diameters 60 centimeter and 50 centimeter. There are two systems having a diameter 60 centimeter and 5 centimeter. What is the force exerted by the larger piston when a 50 Newton is placed on the smaller piston? If we applied a force of 50 Newtons on a smaller piston, then and the diameters are different. That is on 5 centimeter, the force is 50 Newtons. So what will the force on the 60 centimeter diameter 5? So this is the question. Since the diameter of the piston are given, we can calculate the radius. So R is equal to d1 by 2 and d2 by 2. You can see on the screen the radius has been there. Then we can calculate the area also. Area of smaller piston is pi r square. Area of larger pi r square. So we have calculated the area. Now the question in the question what has been asked, how much force is required when exerted by the larger piston and 15 Newton is placed a smaller piston. So maximum force is, you can this is force upon F1 upon A1 is equal to F2 upon A2. We have to calculate the force F2. So F2, if you see that by putting the values, that is 15 Newtons, A2 by A1 and about 30, A2 by A1 pi r square. This is the formula is r square, that is 30 upon 2.5. This 30 upon 2.5. These pi value will be inserted. So 30 upon 2.5 the whole square and into 50 newtons. So what we will get is 7,200 newtons the force which can be lifted by a force of 50 newtons. But just simply a force of 50 newtons can lift a force or a load of 7,200 newtons that can be lifted. So this is one of the greatest mechanical advantage, one of the greatest example of how Pascal law is being used in hydraulic lifts and brakes and hydraulic jacks. This is how very clear-cut example. Hope it has been clear to all the students in this regard. And we can see a smaller video here how the brakes are applied. Hope, but here this is how brakes are applied and how the brakes. You can see here. This is a drum brake. This is a master cylinder here. When the force pedal is applied, when the force is applied on the pedal, the fluid enters into it, and this the brakes are applied. So this kind of, and whenever the pedal is released, look, these are the all the big parts of brake pedal, brake lever, brake coil, master cylinder, wheel rim. Brake pedal with the brake coil, the fluid passes through it, and right. The example of master lifting jack and brake, right? This is a common example. Now, if you see this other hydraulic jack, how is a hydraulic jack used to lift cars, trucks, and other parts. And for example, how hydraulic jack. Here there is a small cylinder. Here inside this is a or a handle. So the force is applied to it, and the fluid is filled into it. This is the larger cylinder, prime which is called, and the force is applied to it. The handle is pulled. Here, the fluid is all is open and then fluid enters it. That there is pulled. Oil enters the bigger cylinder, the force and the load is with common example. How uh, how hydraulic jet works. That is based on common example. In our day-to-day life, we are, hope it is clear to all the students. Thank that with these examples, it might be very clear, right? Thanks for watching, and thanks for